Right now on Amplified, we're about to find out what it takes to build big, build green, and build better. Straight from an engineer who's done it.
They changed the plan and they said, well, you're not going to have a shaft to remove the tunneling machine. So instead, we had to come up with a way of taking the entire thing apart and collapsing it in itself and dragging it 2 kilometres back through the tunnel we had built. And these machines are 130 metres long and weigh 1,000 tonnes.
Today, engineers are expected to deliver complex infrastructure projects and at the same time achieve sustainability targets. While the idea is great, what are the practicalities when you need to tunnel 40 kilometres under a major city or tear up half of a suburban landscape for a rail track? We're about to hear some stories about that, plus how to discover the next great thing in engineering and advance your own career. Our guest has 20 years of experience in all of this to share with us, from achieving 70% carbon reductions to tunnelling under the City of London. It's a pleasure to welcome Group Chief Engineer and Head of Engineering Services at Sisk, Ross Cullen. Ross, how are you?
I'm very well, Dusty. Thank you for having me on your show.
Tell me, Ross, how did you get into this weird and wonderful career we have called engineering?
It's called by accident. Geez, I don't know. I have to go all the way back to spending many years probably lying on my stomach playing with Lego. But it's
good. And it was just in your head.
Yeah, everyone sort of said, you're quite creative, or you're good at figuring things out. But to be honest, I spent most of my youth playing sport and enjoying myself, and thinking about being an engineer was the furthest thing from my mind. In fact, knowing what an engineer was, probably I didn't have a clue. Everyone say, "Oh, you'd be a great engineer." I don't know what that is, but yeah.
Very good. Ross, tell me, when you were first getting into the career, you saw an ad for Sisk. What attracted you to them in particular?
Well, it wasn't even. And so my career journey after I left college was that I stayed in college. I didn't fancy going out into the big bad world, so I did research for 3 years, actually playing with fresh concrete. And then, 7 years was probably enough.
Yeah.
It's time to go out to the big bad world. But a piece of advice I was given was, what's the rush? Once you start working, you're in, that's it. So, take your time. I suppose I followed that, and I went and worked for a consultant in the UK on the design side. So I did that for a short period, and then I wasn't scratching the itch. It wasn't meeting my needs, I suppose. So I then reached out to Sisk, and interesting story. I met 2 great individuals that were able to give me a better insight of myself than I actually knew, which opened my eyes up to how people can change the trajectory of your career in an instant almost.
Why do you say that? What happened?
So it was a great interview. We chatted away for about 2.5 hours. I went back to Birmingham, and I got a phone call the next day, and it was, "We're delighted to tell you that we're not going to offer you the job that we thought we were going to hire you for."
Oh, that's nice.
So I was like, "You're very upbeat about how you're delivering this message." So he's like, "Yeah, well, we reckon you're going to get bored and leave."
Oh.
I said, "That's interesting. Tell me more." And they said, "We got the impression you like to be challenged. So we have a proposition for you to come and work with our current chief engineer and to learn from him and to be challenged." And I was sort of like, that sounds interesting, sounds exciting, and nothing to lose. Why not?
It must have worked quite well because you've been with Sisk ever since. What are the pros and the cons of being loyal with one company?
As long as I'm challenged, as long as you're challenged, there's something to achieve, or there's something you can give, you can add value. That's what's important. And I don't see it as 20 years. I see it as working on part of a project, another part of a project, a different project team. You're working with different people. The beauty about my role as an engineer that kind of looks after loads of areas means I get to help lots of projects, lots of teams, and get to work with different people all the time. So it's dynamic, it's exciting. I'm helping them and they're giving me work that challenges me and my team. So it's interesting. Construction is a people business, and that's what makes it exciting. You meet different people, different skill sets, extremely diverse.
Tell me a little bit about your role, because the official title is Group Chief Engineer and Head of Engineering Services. What is it that you do on a day-to-day basis?
So I have a team of highly skilled engineers that are broad experience and experts at nothing is the way we call ourselves. So we like to take people's problems on site. So how do we build a bridge across a big river? How do we get the tower cranes to stand up? How do we get the double basements to support themselves and not impact the neighboring buildings? So we take those challenges and we work through them and come up with solutions for the project teams. So project teams have endless lists of problems that they're dealing with. We are there to help them take a problem that's frustrating them. We get to work in it and give them back a couple of options or solutions. So we're helping them. So we get to do that on all the projects across Ireland, UK and Europe, in all the sectors, from data to life sciences to civil engineering to buildings. So it's a variety.
I'm just thinking, for somebody who's listening now and the more in the day-to-day engineering side of things, if they want to make the transition from technical engineering to, kind of management or leadership, what kind of skills do you think that they need to brush up on?
Yeah, so it really is people skills. You need to have a grounding of good knowledge in your discipline. So as an engineer, you pick up all your skills. You come out of college, you're trained as a problem solver. Everything else you have to learn on the job. You learn from your supervising engineer, your senior engineer, the subcontractors you work with. You're constantly building up knowledge and you learn from problems. You learn from what's caused you pain. You don't learn from what goes well, because when something goes well, it happens and you go through the motions. But when something goes wrong, you go, well, what went wrong? And we're trained to think about analyzing, why did that happen? How can we improve it? What are we going to do the next time? So you're constantly learning, and there's different solutions and different tools for every situation. So as you're increasing your toolbox of skills, the more you have in your toolbox, the more equipped you are for then progressing through your career.
If you need people's skills, then is that something that you pick up if you play sport, or is it something that can be learned by doing a course, or is it just something you pick up as you go along, as you said?
Every facet of life. But sport is certainly, I think if you compare construction and you compare sport, there's a lot of similarities. People in construction like to be part of a team. They work well as a team, and you similar dynamics to sport. So you're working for a common goal, and there needs to be alignment on that goal. And obviously a good leader is able to galvanize the team by getting consensus of what that goal is, because the goal is obviously to make sure everything happens safely. The quality of workmanship is right, and things are planned and happen on time. And also the goal is recognizing that not everything is going to go to plan all the time, and how do we react defines us. So how do we stop, assess the situation, figure out what went wrong or what's going to go wrong, reset, move forward.
All right, Ross, let's chat about some of the projects that you've worked over your career. How many projects would you normally work on at a given time or in a year?
Oh gosh, we could consult on nearly 100 projects in a year.
Whoa!
But that's like everything from, the gate at the site entrance to...
All right, okay. Well, listen, let's pick up on some of the bigger ones. One of the first ones I know that you worked on was the tunnel at Limerick under the Shannon. Tell us a little bit about that.
Yeah, let's turn back the clock now, Dusty.
I know. It was your first baby.
It was my first baby, and I was sent down. So yeah, I was learning is the only way to describe it. But we all have to learn somewhere. But what a fantastic job! It was a 4-way joint venture, and it was constructing 500-meter long sections of tunnel in the dry dock that we had excavated out of the north of the river, and then we constructed temporary structures through the riverbanks, and we essentially flooded the dry dock, and one by one we floated up the 100-meter long tunnel sections and brought them out into the river and sunk them down into a dredged channel and linked them all together. So it was a fascinating job, but I suppose what really stuck by me was I was sort of looking after coordinating a lot of the marine works, and the big thing about marine works is you've nowhere to stand. So when people are planning work, you always have to be thinking, well, where are the people going to be? Where's the equipment going to be? And rule number 1 of marine works is get out of the water. Don't get your feet wet. Keep everything up on land or structures that you build out in the water that's not going to rely on the tide. So it was interesting. And I got to work with a lot of really experienced people. So there was a number of people working in that job that worked on the jetty in Nish back in 1979. And they had all ended up, after being all over the world with different companies, back on this project, some of them towards the tail end of their careers. And someone said to me, pulled me aside one day and was like, you realize the opportunity you have working with all these people with all this experience. Your job is to go and speak to them, extract stories, knowledge, get to know them and try and learn from them. And they were all so generous with their time, incredible mentors, and just they challenged me, and I was getting information from them the whole time, and it really gave me a good foundation going forward. So as an engineer, our advice to people coming out of college is be inquisitive, ask questions, because people are incredibly generous with their time if you ask the questions and you show an interest. And I genuinely was interested, and I believe that really helped me get my understandings and my foundation elements.
Do you have any examples of, because they say there's no such thing as a stupid question, all right? Have you ever asked a stupid question in your life? And how did you feel when you got the answer?
I don't think I have any examples, but I think I ask stupid questions every day. And I think the more experience and the higher up you get in an organization, you need to make sure that you're asking questions in the room.
Yeah.
And even if it's a silly question, you can ask a question that's sort of segueing off that, because it then shows everyone else that they should be asking questions and invite them in. So providing safety to people to know that you need to be inquisitive. There's no problems with that in Sisk. Everyone asks questions all the time, and it's good to confirm.
It's an engineering trait to ask questions anyway,
Yes.
isn't it? So there you go. Listen, another big project that you worked on over the years was Crossrail in London. Now that's a huge thing. It was going from the west of the city over near Heathrow, right underneath the city and over to the far side to the east, 42 kilometres long. What's the one outstanding memory you have of that gig?
One.
What's your favourite? Which one?
Oh, it has to be the team. So we were involved in tunnelling from East London through to Farringdon, which is in the centre, and we met the other consortium tunnelling from the west into Farringdon. So they arrived before us, and they swung a hard left and a hard right, and they buried their tunnelling machines. But they got there before us, and we arrived then with our tunnelling machines, and there was nowhere for them to go or to be buried. So the biggest memory, or one of the best memories, there's a couple of memories, but some of them were like, you're approaching a station, you have to extract the machine out of the head wall and into the station and drag it through, and you'd be trying to figure out, well, how are we going to do that? And you'd be working on the engineering about trying to, how will we safely receive it into the cavern? But you'd be tunneling and you'd be going towards it, and every day it's getting closer and closer and closer, and you're still arguing about, should we do it this way, should we do it that way? And there comes a point where it's like, we got to decide, we got to make a decision, because we're not stopping, so it's pressure comes on. And that they were the best times. It was healthy debate, but then it was like healthy debate, but we had a deadline. So let's crack on.
Can I ask a stupid question?
Absolutely.
You said that you went left, right, and then you buried the machine. What do you mean exactly by that?
The tunneling machines, they have an outer skin, and then you have all the equipment inside it. So what they do sometimes in tunneling, if the tunneling machine is bigger than the tunnel that you make, so you can't take it backwards. And because they were tunneling first, they had nowhere for it to go because there was no shaft to take it out. So what they do is they just go off the alignment and go into the ground, and then they take the machine apart and just leave the outer skin, and then they pump the skin full of grout and leave it there. So because there was no space left for us, and we were meant to receive a shaft to take it out, and then they changed the plan and they said, you're not going to have a shaft to remove the tunneling machine. So instead we had to come up with a way of taking the entire thing apart and collapsing it in itself and dragging it 2 kilometers back through the tunnel we had built. And these machines are 130 meters long and weigh 1,000 tons. So the first 120 meters are easy to take out, but the 10, 12 meters at the front, that's bigger than the tunnel. That's quite a challenge. So that was interesting. It was, but we had a great team, worked with some really, really creative people, solved the problems. It was good.
Well, listen, getting away from that, you were back in Ireland then, and you were involved in the Luas Cross City project. Did you learn anything from Crossrail doing the underground tunnels that you were able to apply to overground with Luas?
Well, I suppose the whole time you're improving your skills on how to deal with people. So different challenges, but the challenges are always with people or involve people. So how do you agree on something? How do you convince people that change is required? Coming up with a good idea
Mm,
is the easy bit with anything. So as engineers, we're always trying to make things better, but sometimes making it better isn't the right thing to do
mm,
because what's the impact? Does it add value? Does it increase functionality or does it reduce risk? Is it safer? So you got to weigh up what are all the elements. And then you got to go, right, okay, we now have to sell this to
mm,
all the stakeholders that we want to change the plan. And sometimes you have to weigh up how long is that going to take? How much time and effort is it worth it? So I suppose from Crossrail, my learning was pick your battles. Don't go after everything. Pick what's important, what's going to add the most amount of value. And this is infrastructure we're talking about. It's going to be in place for 100 years plus. So, short-term gain or long-term. So it's about what's right for the stakeholder. What's the ultimate user of this? Is there a benefit to them?
Moving on then, you were also involved in Pearse Street, the train station in the centre of Dublin. Quite a big project. Tell me about that.
Yeah, so we had to replace the existing structure, the roof structure, over an operational railway line.
Mm.
So we worked with the client Irish Rail, and the original plan was to close the railway for, I think it was like 13 weekend possessions. And that's fine in a way, but you've got to mobilize all your workforce to work these long weekend possessions. So if you do one possession,
Mm.
that's okay. It's an awful lot of planning involved, but to do 13 of them is a challenge for the supply chain, for the site team, for everyone involved, and it's high pressure, repeated because you have to hand back the railway after every possession so that the trains can run and people can get to work on a Monday morning. So we developed with Irish Rail, we have a great relationship with them, and we developed a solution where we built a steel structure over the platforms and over the tracks and the overhead lines. And we built a steel deck, and then we put a platform which moved along the station with a high-ab crane. So, the knuckle boom cranes that you have on the back of trucks. We bought one of those and we modified it and put it on a steel frame.
Hmm.
And we had that above the railway tracks, and we used that to demolish the existing roof and to build the new roof in stick base. So we'd take a truss and we'd install it in sort of three components, and prop it as we put it together. So we moved this window along the whole length of the station of taking the trusses out, putting the new ones in, doing the glazing and the finishing works. And it meant that we could operate on a Monday to Friday during the daytime.
Hmm.
We could have all our steel and glazers and our fitters all working in a normal sort of shift pattern. So you have people that are, not working all weekend. You're not dealing with fatigue. You're not under high pressure situations to hand back the railway after each weekend. So there are benefits to it. And ultimately we ended up with replacing the roof successfully. The client got what they wanted. Our supply chain wanted to work a normal shift pattern, and it was a great success. But it shows that you have to have good relationships between the contractor, between the client. You have to have trust, and you have to make sure that you're doing it for the right reasons. So we were doing it ultimately for safety, really, because it's a high pressure situation, and if you're against the clock all the time to hand back an asset, it's not a position you want to put people in, working late at night, long hours.
Ross, I'd like to move on to a topic that is just huge in engineering and for the planet in general, and that's sustainability and decarbonising and that whole thing. I know you're quite interested in decarbonising construction. When you talk about decarbonising construction, what do you mean?
I mean, using materials that emit less carbon dioxide into the atmosphere in their production.
Okay.
So if you take concrete, for example, is made with cement, and typical cement is produced by burning limestone and shale, and that process emits carbon dioxide. So 8% of global emissions of carbon dioxide is from the producing cement.
Okay. Is another silly question. Is there such a thing as decarbonised concrete?
There will be, I suppose. And this is the question.
Yeah.
So there's lots of talk about different technologies which can be developed. But if you take the existing process, which is universal, there are talking about trying to do carbon store and capture. So taking the carbon that's emitted during the chemical process and either capturing it and storing it somewhere. So that's one way. Or there's other products like geopolymer type cements and concretes
Okay.
that actually don't involve burning limestone and emitting carbon dioxide. So there are other technologies, but the likes of a geopolymer concrete, you're never going to create the same volume that's required to replace all the cement that's produced globally. So I think when we talk about decarbonising construction, I think first of all, we got to look at, so before looking at any sort of technology improvements in producing cement or different products, we need to use our resources wisely. So that means making sure that we have efficient designs that use the appropriate amount of concrete. So that means leaner design, but at the same time, we're designing infrastructure that lasts for 120 years. So you have to make sure that you strike the right balance. So it's really important. It's a safety issue.
So keeping all that in mind then, are you working on any initiatives or anything new to do with low carbon concrete?
Good question, Dusty. So we have a couple of initiatives that we've been involved in. So we're working with universities here in Ireland to assist in developing cements using industrial byproduct. So that's research that's ongoing, and our part to play as a contractor is we want to support and facilitate. So when it comes to doing, say, a site trial, that we will facilitate and make some resources available and some space available to produce this concrete and build a small, say, demonstrator or test piece on our project so that we can then see how it performs, because what's done in the lab needs to be replicated in real life. So that's one example. And then another example was in the UK, we applied for funding and we were successful in a consortium of 7 bodies.
Right.
And we built a low carbon scalable demonstrator in the UK, and we achieved a 70% carbon reduction, which isn't insignificant. And the whole purpose, or the what was interesting about it was, how do they call it? It was described as boring. So the concrete looked the same, flowed the same, set the same. So in terms of using a product that's globally the same, well, not all concrete's the same, but it flowed the same, it went into the shutters the same. When the shutters were struck, it reached the same strengths. And, so we were able to demonstrate that a low carbon concrete technology is the same, but with less carbon.
When you're trying to do something new and you're trying to bring in, and this applies not just to your team, but also when you are, kind of working with other people, like clients or interested parties and that kind of thing, and you're trying to do something new, what kind of approach do you take if they're kind of going, I'm not sure?
Oh, as engineers, we base everything on fact, on numbers, on being able to predict what it's going to be, how it's going to behave. So we deal in the black and white. Absolutely.
Listen, let me ask you about looking for those things and finding newer ways of doing things, and how do you find these things?
Well, we've got a great team here. And we explore what's out there in the market, different techniques, different materials. There's always people innovating. And if you talk to enough people, you'll find out who's innovating and who's coming up with different products. And it's just about exploring them or different forms, or let's just take a building. Typically, people don't want any internal columns. They want big free spaces. But in apartment buildings and stuff, you don't need all those big free spaces because the grids can be rationalized. So you can then economize on the size of the columns. You can reduce the floor thicknesses. You can use less concrete in all these type of areas and not really impact on the structure. And if you sort of refine everything in the building a little bit, you make a big saving. So it's incremental or marginal gains is where there are savings.
And it's just kind of keeping your radar open. I mean, do you solely rely on talking to people within the industry to find new things, or do you look at particular websites or YouTube channels or particular TV shows? Or
That's a good question. I mean, I suppose we're all dialed into everything. It comes down to our networks. And if I roll back to right at the beginning of my career, talk to people, learn from them. And the more people you get to know, the more bits of information you get. You read the trade press, and you find out what's going on. And as contractors, we're always trying to push the boundaries. We're always looking for what's the next thing out there. How can we deliver? Because it's a very competitive market. How can we deliver savings to the customer and not impact the functionality of what's being delivered? So, and the customer is also challenging us more and more, especially on a sustainability perspective. How can we lower the embodied carbon in our asset? They're asking us. So we're then coming along and, well, we could do this, we could do this, we could do this. And it becomes a shopping list. But sometimes that shopping list then pushes the price up. So what's the cost that they are willing to pay sometimes to reduce, because to use less materials? So if you go back to, say, maybe the 70s or 80s, and you go around, say, UCD, you'll see what's called like waffle slabs. So you'll see the soffit of the roofs and they're all waffle shaped. And that's because it uses less concrete. Less concrete is less carbon, less materials. But to build waffle slabs it's slower, uses more labor. So, material versus labor versus time. Time is money, labor costs money. They're the trade-offs.
Everything has to be factored in. I'd like to ask you a couple of questions just about kind of moving on in your career, because I believe that you speak about how understanding yourself is key to owning your career. What do you mean when you say that?
Yeah, that's a good question. When we have graduates come in, we do a day talking about, engineering and what we do in technical services or engineering services in terms of providing support to the projects. But I always spend a bit of time telling them, I suppose, my story about you need to be inquisitive. You need to take ownership for your own career, because people, they leave university, they enter into graduate programs, and we have very structured graduate programs to try and give as much opportunity to learn in an accelerated fashion, these engineers, to get them across all the disciplines and to learn. But they reach a point where they get to the end of that graduate program where it's sort of being laid out in front of them. And they need to learn from an early stage that you need to take some ownership for your own career. You need to decide fairly early what you like, what you don't like, because it's important to rule out certain things. And if you want to stay motivated, you need to do what you love. I love what I do. I skip into work every day. And that's because I was clear about what I didn't want to do early in my career. And I wanted to be challenged. So that's the route I went. So people need to own their careers. That's my advice to young engineers. Ask questions and figure out what you don't like as well as what you do like.
And then I think you've also said that engineering is a passport to opportunity.
That's correct. Yes. I mean, gravity is the same the world over.
That's good.
There are obviously intricacies in terms of codes and standards. It's a people on the contracting side. It's a people business.
Yeah.
So, you learn how to deal with people and problems. So look, if you're a good engineer, the possibilities or the opportunities are endless. And that's how I ended up in London for 5 years. It was, here's an opportunity. Yep. Let's go. So it's a great opportunity to travel and learn different cultures and learn from people with different cultures, because that's how you hone your skills. You can't just work with the same people all the time. You won't learn. You need diversity, and construction is very diverse.
When you were coming up the ranks yourself, Ross, did you ever have a mentor? Did you use somebody like that?
Yes. So my previous chief engineer was my mentor. He kind of challenged me all the way through my career, and let me make my mistakes to learn in a safe way. And I think it's really important to build a good relationship with your mentor, and it works both ways. And it's really important. But you can have a mentor or a line manager, but you can have several, because you learn off each other. So that there are always accidental mentoring opportunities for everyone in the industry, I think.
Well, if you'd like to find out more about Ross and some of the topics that we spoke about today, you'll find notes and links and details in the description area of the podcast. But for now, Ross Cullen, Group Chief Engineer and Head of Engineering Services at Sisk, thank you so much for joining us today and sharing so much with us.
Thank you, Dusty.
If you enjoyed our podcast today, please do share with a friend in the business. Just tell them to search for Engineers Ireland in their podcast player. The podcast is produced by dustpod.io for Engineers Ireland. For advanced episodes, more information on engineering across Ireland or career development opportunities, there are libraries of information on the website at engineersireland.ie. Until next time, from myself, Dusty Rhodes, thank you for listening.